Hello and welcome to Amit's Tech Sessions. My name is Amit, and in today's video, we are going to talk about EKS Pod Identity. And we are going to use this whiteboard to understand EKS Pod Identity. Before we dive into EKS Pod Identity, let's try to understand how basic authorization works in Kubernetes or in EKS. So let's say this is a EKS cluster. And in this cluster, we have a namespace. And within this namespace, let's say we have a pod. As a user, now you want to access some information on this pod. So how does that basic authorization flow works? Let's try to understand that. In Kubernetes, every request is fronted by the API server of Kubernetes. Now let's say user requests a pod information through kubectl command. So kubectl command goes to the API server. Then API server performs a basic authentication first. And in authentication, Kubernetes validates that who you are and are you the right identity for this request. We're not going to go into authentication in deep here, but then after authentication, there is an authorization which is performed, and this authorization request is validated through two key components. One is cluster role, and another one is role. So cluster role is scoped to the cluster, to the EKS cluster, and role is scoped to the namespace. So authorization request goes to the cluster role or the role. And if cluster role or that role has permission to access that pod information, then information is returned back to the user via the API server. So that's a standard flow of authorization, how it works in Kubernetes or in EKS. Now let's understand another scenario where this pod here might need to access some information on Kubernetes via the API server. So how do we provide this permission to the pod? For that reason, Kubernetes has a kind object which is called service account. So service account is mapped to that pod, and service account also has binding to the role or the cluster role. So you can bind a service account to the role through a role binding, and you can bind a service account to the cluster role through the cluster role binding. So this service account is mapped to the pod. And all those permissions which are assigned to this cluster role and role are now acquired by the pod, and pod can perform the operations through the API server of Kubernetes. So this is another flow. Now let's go to a third flow where this pod here in EKS cluster needs to access a service in AWS. And let's say this service is an S3 bucket. So in order to access this S3 bucket by the pod, we have to create an IAM role in AWS. This IAM role will have the permission to access this S3 bucket. It could be, let's say, get bucket or list buckets, etc. So this IAM role will have the permission to access the S3 bucket. Now, how do we bind this IAM role to the pod? You don't bind IAM role directly to the pod, but you bind this IAM role to the service account. And this binding is done via an OIDC provider. So this binding is done via the OIDC provider. So this whole binding of IAM role to the service account via the OIDC provider, this is called IRSA. This was the feature which AWS has to bind the IAM roles to the service accounts. It is called IAM roles for service accounts. This was the flow before EKS Pod Identity came into the picture. So now in EKS Pod Identity, you still have IAM roles, but you don't bind those IAM roles to service accounts using an OIDC provider. You have IAM role, which will have a trusted principal called pods.eks.amazonaws.com. So that's the principal you have to put into your IAM role so that pods inside EKS can assume this IAM role to perform the operation. So this is the difference between EKS Pod Identity and IRSA. The advantage which EKS Pod Identity gives you is that you don't have to bind your IAM roles to service account using that OIDC provider. Plus, you can use this IAM role across multiple clusters. In IRSA, you cannot use one IAM role across multiple clusters because your clusters have different OIDC provider. But here, your IAM role can be used across multiple clusters. And if you want to scope your IAM role to a specific cluster in EKS Pod Identity, you can also do that by having a condition statement in your IAM role conditional block. So in summary, to achieve EKS Pod Identity, there are 3 major steps which I'm going to put here. So first one is create the IAM role, and in this IAM role, your permissions, assign your permissions. For example, s3 get object, and put your principal in that IAM role pods.eks.amazonaws.com. So that's your first step. And your second step is install or deploy pod identity agent in your EKS cluster. So pod identity agent is available as an add-on inside your EKS cluster. So you can install that add-on into your EKS cluster. What this add-on does, it installs an agent on your worker node where your pod is running. And then the third step is create an association among these objects. So you have to create an association among namespace, service account, and IAM role. So this association you need to create in the EKS cluster, then only your pod identity will be effective. So that is all about EKS pod identity. I hope this was useful for you. In a nutshell, EKS pod identity is a new way to use IAM roles for your pods to access any of the AWS services. This eliminates the need to map your IAM roles to service accounts using the OIDC provider. EKS pod identity was announced at reInvent 2023, which was in December 2023. So that's where they announced this feature, and this feature is now being used widely by the EKS cluster users. That's all. If you like the content, if you like the video, press the like button and don't forget to subscribe. Thank you.